There we go. How does that work? Okay, then I need to display settings. That's what I want. There we go. Okay, I got it. Okay, now we got it figured out. So, oh shoot. I thought I had it figured out. There we go. I just want to move this guy out of the way. There. Okay. Well, that didn't change over though, did it? There. Okay. Now that's better. All right. I'll figure this stuff out eventually, y'all. Then they'll change it again. Just so you know, it'll get changed again. All right. So metric system. When we're talking about the metric system, everybody gets like so worried about, oh, I don't know how to do that. It's not hard. All you have to do is just slide the decimal point one way or the other. You got to know where you're starting from, where you're going to, and then you just slide the decimal the same number of steps it took you to get there. Okay? So don't get like all anxiety, and everything about this because it's not bad. Just let it come. Okay? Primarily, when we're working with the metric system, we're starting with kilo and we're going down to milli. Okay, this is the section that we work in most of the time in here. There are some that are a little bigger and some that are a little smaller, and when we get to those sections, I'll show you how to do them. Okay, that's primarily chapter 5 in here. Okay. Is this right? Does this look right for you guys? Yeah. Okay. So I have quantities for these. We have mass, which is kilograms. The base unit for that, though, is grams. Our balances measure in grams. Length is a meter, so meter stick. And the abbreviation for that, the base unit is an M. Time is seconds, and we can have like milliseconds and that sort of thing if you've ever heard of those. Sometimes they'll do that in sports. Temperature is Kelvin, and we'll get into that. Can we do that today? Yeah. We'll talk about that a little bit further today. Current. We don't really do much with current in here. If you take physics, they'll do some with that. Touch, maybe one day current in AP, but that's about it. Amount of a substance, we use this one a lot. It's called the mole, and we'll get into that real hot and heavy next semester. And then they have luminosity, which is candela. But again, we don't do anything with that because that's just primarily physics. All right, here, when we have this, we always have our base unit. And down from that is deci. We're going to put the D and then whatever the base unit was. So if this base unit was meters, okay, decimeters would be DM. Centimeters would be CM. You've got 10 of these in every one of these. You have 10 of these in every one of these. So you've got 100 of these in every one of these. Does that make sense? Milli then is M. I don't know. There's probably terms for these. I just don't know what they are. We have two more like placeholders here, and then we get down to micro. And then you can have two more placeholders, and then that gets you down to, I believe, nano. Yeah. So 10 to the minus 9, the prefix is nano. And the abbreviation for that is N. And we do use that a little bit in chapter, we'll get into chapter 5. On this end, we have mega. And then beyond that, we have giga and tera. And you've probably heard of those in terms of computers and measuring bytes. We only go up to mega in here for our stuff. So. Now, you can either multiply by these things or divide by these things to get to where you need to be, or multiply depending on which side you're going. Or you can just slide the decimal. And that's the way I do it. Okay? Did I skip? I feel like I skipped a whole bunch here. I must just be covering it in the I do. I'll do some examples when we get to the I do. All right. Temperature, when we're talking in terms of Celsius, and that you've probably heard of Celsius before. Okay. That's what most of the countries measure temperature in, except us. We measure in Fahrenheit. I put this up here just so you would have kind of perspective about it. We don't actually do anything with Fahrenheit in here. We don't do any conversions into or out of Fahrenheit. So you don't have to worry about that. That one is a little icky as far as trying to figure out the conversion. It's like 9/5 times minus 32. It's just a mess. Okay, so we don't mess with it. These are the two that we need to worry about and converting between them, because we do this quite a bit during the year. So let me talk about what Kelvin is. So Kelvin is a measurement of molecular motion, essentially. So everything around you, doesn't matter what you look at, everything around you is vibrating. Okay, some things are vibrating in place, like your desk and anything solid. Okay, but they have a certain amount of molecular motion, and we can measure that molecular motion in terms of temperature. If we were to cool this down and keep cooling it and keep cooling it, eventually that molecular motion is going to slow down. And eventually we can get to a point where there's no molecular motion. Okay, in theory. I don't think that they've actually accomplished it yet. People are trying, like these really nerdy people in like labs around the world are trying to get to absolute zero. Some people feel that it can't actually even happen. So where all molecular motion stops, we call that 0 Kelvin. Where water freezes, it is 273 Kelvin. And water boils at 373 Kelvin. If we look at that in terms of Celsius, it's going to be a negative 273. Water is going to freeze or melt at 0 degrees Celsius, and it's going to boil at 100 degrees. So you need to be able to convert between these two systems. So Celsius will equal Kelvin minus 273. And I have those at the bottom of that page down there. I have those formulas for you. Kelvin then is degrees Celsius plus 273. Kelvin values can never be negative because you can't go below absolute zero. You can't make motion stop more than zero. Like if it's stopped, it's zero. You can't go negative from there. So Kelvin can never be negative. You can never have a negative Kelvin value. If you got a negative Kelvin value, you goofed something. Double check your work if something's wrong. If I have a negative Kelvin value in an answer key, I got it wrong. Okay. We did find one little minor hiccup on the answer key from yesterday, and I uploaded a new one. So if you caught that, it was number 6 on there. So sorry about that. Let me pull it up real quick while we're thinking about it. If this will let me exit out of here. I don't know how to do this stupid thing. Sorry. Well, I think we're just perpetually stuck here. Oh, that's why. I didn't see that. Answer key is over here. Answer key for you guys. So number 6 on the original answer key, I had the wrong value down here. It should have been 100 on the bottom, and then the answer should have been 3.8%. So sorry about that. I got it fixed and I uploaded a new version to Classroom, but I don't know if it stuck or not. All right, let's try this again. Okay, so then if we look at density, when we're talking about density, remember we talked yesterday about how that is love. We have our unit, we have mass over volume, or an M over a V, if you need to remember the formula. Whatever units your mass was given in is going to come over here and it'll be the units for your answer. So if your mass was given in kilograms and your volume was given in liters, then your units for that density would be kilograms per liter. Okay. In lab, you're going to be doing some of these. You're going to be measuring things in grams. You're going to be measuring your volume in milliliters. So your units for density then would be grams per milliliter. Other things in lab that you're going to do next week, you're going to have grams, and then you're going to do length times width times height with a centimeter ruler. Well, centimeters times centimeters times centimeters is, right, centimeters cubed. So then your density would be grams per centimeters cubed. So whatever you have for your mass and your volume, they carry over to give you your density. That makes sense? All right. So here are I do problems. First one, we're going to convert from 0.2005 meters into centimeters. So I'm going to have my metric. This is my base unit here, which in this case is going to be meters for this one. Okay, so I'm going to find where I'm starting on this line. I am starting with my base as meters here. And I'm going to count how many spaces I need to go. So 1, 2. I started here. I went 2 spots that direction. So I'm going to take my decimal point and I'm going to move it 1, 2 spots. So my answer ends up being 20.05 centimeters. You're just sliding the decimal point the same number of spots that you slid on the line. Does that make sense? Can you do that? Does it make sense that if I had a meter stick and I had 20 centimeters, or 20, it was this much of the meter stick from my fingers here to here, that would be 20 centimeters? Okay, it's divided 100 times. All right, any questions on how to slide the decimal point that way? I think this is probably, I'm hoping this is a review for you from other classes. All right, let's look at this now. If I change this over, and this time I'm going from DL to DAL. So my liter is my base unit in this case. I'm moving from here. I'm going to go 1, 2 spots. This time my decimal is going the opposite direction. So I'm going to go 1, 2, and my answer will be 0.2308, and that will be DAL. Does that work for you? Can you do those? You just slide, slide, slide. I will give you this on your first test and your first quiz. Okay, so I'll give you that sequence there. You can remember it. King Henry doesn't usually drink chocolate milk, is what the kind of, what do they call that? Mnemonic device?
I think so.
Yeah, I'll go with that. All right. I will not mark you off on this, but notice that Kelvin does not have a degree sign. Kelvin's not measured in degrees. Okay, so it's just 83 Kelvin. If you write a degree sign with Kelvin, I'll mark it, but I won't take points off. Okay? All right, I want to go from 83 Kelvin to Celsius. What am I going to do? Back at your notes, what does it say to do to go into Celsius? Yep, so I'm going to subtract. So I'm going to go minus 273 here. Oh, I didn't do this. So I got negative 190. Is that what you got?
Yes.
Okay. Now Celsius can be negative. Kelvin can't. So here, you do not want to end up with a negative number. So here, what are we going to do to get to Kelvin? Add 273. All right, so I ended up with 356. So 356, and again, notice that I did not get a negative value there for, or a negative value, and I also didn't put a degree sign for my Kelvin. Bueno? Pretty good? All right, one more I do problem. We've got brick of salt. It's measuring 10 by 10 by 2 centimeters, and we were given a mass. We want to calculate the density. So the first thing I need to do is I need to calculate my volume. So my volume is going to equal 10 times 10 times 2. So what is that? Do that in your head?
200.
200. And what are my units on that?
Centimeters.
Cubed, right. Okay, so it's going to end up being 200 centimeters cubed. I don't know why my line went away. Let's try it again. I'm going to put my mass above here, which is 433 grams. And notice if I put my units in my work, they just flow right over into my answer. So 433 divided by 20 is 22. And that's going to be grams per centimeter cubed. Divide this by 200.
You said divided by 20. Yeah,
20.
You divided it by 20.
There, better? It's been a day, you guys. I spilled my coffee. So 433.
Shouldn't it be 200? Yeah, shouldn't it be 200? Because 10 times 10 is 100 times 2 equals 200.
Yeah, it should be 200. What am I doing?
It would be 2.2.
Ay, ay, ay. I can't do, I don't seem to be able to do much of anything right today, you guys. Yeah. Well, like I said, coffee. All right. Is that better? Did I mess up anybody? Did I confuse anybody with my bad math?
I think we're good.
Okay. All right. I'm going to switch over to the next slide. This is the we do. So we got a couple we do problems. I want you to see if you can come up with the right answer. Okay. If you haven't written this guy down yet, you probably want to have him somewhere handy.
Should I write
just every time we do problem with this?
You don't have no. I mean, if you need it, write it down. If you're like, I got this, I don't care. I just if you haven't got it written down anywhere or you don't have it memorized, then people probably need to have it down because they're going to need it tonight for homework, and you're going to need it a lot throughout even the year. To be honest with you.
How do I use this system for weight? Or like the customer system?
This becomes grams right here. So that can be grams, it can be liters. Remember when I talked about back here, we had all of these. So it could be a meter, it could be a second, it could be a mole. There's lots of different things that can be. So that's your base unit. So whatever they're measuring in. So grams, liters, meters. Those are the three most common. So whatever that is, that base unit is your, so for this one it's gram, for this one it would be meter.
Where would kilogram go into this?
So kilogram would be right here.
Because of the K?
So kg, yeah, the K. The base unit is your G. So you could have so for that would be kg, hg, dag, g, dg, cg, mg. And then if you had liters, you would change this to liters, and then everywhere you've got a G, you're going to change that to an L. So that would be KL, HL, DAL, DL, CL, ML. And this would measure volume. So this measures mass, this measures volume. I want to do it for length, and I'm just going to change the L to an M. So this would be a meter. This would be a kilometer. Hectometer.
Oh, I see. So
decameter.
So you add for the first one, you added a G at the end of it for the abbreviation.
And this
the
one
liters,
was L's for liters. And this is going to be M for, so this would be decimeter, centimeter, and millimeter.
Okay, I think I'm starting to get it. Thank you.
Yep. So this would measure length. So this is length. This would measure volume, and this measures mass. All right. As you're working through this, I have my answers up here. if you didn't get these 2 answers, I want you to call me over and let me help you with it, okay? If you did get those 2 answers, I think, yeah, you're just going right into the homework then, okay? There's several problems for this homework too. So there's 22 problems, okay? It's 2 pages, but my guess is you're going to get a lot of that done in class because you're just sliding decimals. Check my answer key. I'm hoping I got everything right, but we've seen with experience that that's not always the case. So cross your fingers.